In this experiment, I will try to calculate the friction force between an object and a horizontal surface by using a spring as shown in this setup. I will stick the spring onto a wall, compress it, and release the object. I will measure the compressed length, distance traveled, and the duration. To calculate the friction, I will first use the work energy theorem, and from this theorem we can find friction as kx squared over 2d. I will check if my first result is consistent with the result given by Newton's second law, which can be stated as 2md over t squared. First, in here, I measured the natural length of the spring I will use, which is 10.5 centimeters. Then I stretched the spring using a dynamometer to 5 newtons. And I also hang a puck from it to see how much it stretched. I hang objects of different masses to see how much the spring stretches, and by plotting a graph, I find the spring constant to be 80.131 newtons per meter. Then I measured the mass of my object, which is a wooden cube, and it has a mass of 29.09 grams. Now the experiment. I first compress the spring by 2 centimeters. The cube travels a distance of 22.5 centimeters in 0.32 seconds. Then I compress the spring by 2.5 centimeters. The object travels 28 centimeters in 0.47 seconds. Now 3 centimeter compression. The object moves 38.5 centimeters in 0.51 seconds. Next is 3.5 centimeter compression, in which the object travels 51.5 centimeters in 0.57 seconds. Then I compress the spring by 4 centimeters and the object moves 59.6 centimeters in 0.63 seconds. Finally, when I compress by 4.5 centimeters, the distance is 70 centimeters and the duration of motion is 0.69 seconds. Here I put all the data I mentioned in a table. From this table, I draw another one that relates energy to distance traveled. And I plot a graph from these values. The slope of this graph is equal to 1 over friction, hence I calculated the friction to be approximately 0.124 newtons. From table 2, I plotted the graph of d versus t squared, whose slope gives us 1 over 2 acceleration. Therefore, I multiply the slope by 2 and get the acceleration. From Newton's second law, the friction force is approximately 0.087 newtons. You can also see individual values of friction I've found for each trial here. By using the theoretical value of friction between wood and wood, which is the closest theoretical value I could find, I find percent error in my experiment. I find out that while the work energy formula has a large error of 45.02%, Newton's second law has a minimal error of 0.02%. This is mainly because of the non-linear spring constant, and also because of me giving a slight tilt to the spring towards the bottom, left and right. This causes rotation of the object. However, with F equals ma, the only possible room for error is not measuring the time correctly, which causes minimal error overall.